Now the last features are we're going to buzz around the outside of the profile to remove material. Corner rounding end mills don't work too well. They only need to take off, they have to take off just a minimal amount of material. So we're going to have to go in with this end mill and make a sharp corner for it to remove. Now the tip on our corner rounding end mill is 1/4 inch, so it's the same diameter as this cutter. So that said profile is going to have to be spaced off a little bit, otherwise both sides of the radius cutter will be cutting on the right and left of the part. And we just want it cutting on our part. We're going to go 2D milling, we're going to do a contour, and we're only going to cut the depth of our fillet. We want to leave the rest of the block square so that we can hold on to it. If we cut part of the way down, we'll have probably a witness mark. And so if we cut the bulk of the steel from the opposite side, then it'd just be a blending thing on the radius itself. Okay, so we're going to go to heights, and we're going to leave the first view at default, and we're going down to the contour. And let's take off 0.005, and what that will do is make sure that the very tip of the corner rounding cutter isn't touching. So we're going to do wear compensation. We're going to do roughing passes in X. I want to leave a substantial amount of material behind, so or a substantial amount of material to remove. So our roughing passes, they're still going to be 0.03. But we're going to do, let's do 3 of them. Okay, and that'll leave a sizable channel on the one side so that the corner rounding end mill isn't cutting very much on the scrap side. We're not going to do multiple depths because this is only a 30-second deep. Select smoothing because we're doing arcs. I want to double check our finish pass. Our finish pass is currently set at 25 thousandths. I'm going to set it at 10 just because this is steel. Okay, we're going to go to the next tab. And similar to how we did the end, we're coming in off the edge of the part. So I don't feel there's a need for a radius. And we're going to come in at 0 degrees to our profile. We're going to go 0.1 for that lead in. And I don't see a need for a vertical lead in, and we'll do our lead out is the same. So we'll see how this works, and we'll hit accept. Alright, so we have our lead in. It's in green. We have a couple rough cuts, looks like 3 rough cuts, and then a finish cut. Okay, so our last profile is our corner rounding end mill. So we're going to go 2D contour. We're going to select the same profile we had, but we're going to go and we're going to switch to our corner rounding end mill from our library, which is tool 21. Looks like we can leave the RPM where it's at. We're going to stick with all our heights. We're going to go from stock top to the contour. We're not going to adjust any of that. We're going to use wear compensation. Okay, and we're not going to do multiple finish passes, but we do want to put a finish pass of 0.05. Rough passes, we have to do at least one rough or we're not going to end up with anything. And we're going to just do a rough pass of 0.01. Okay, a finished pass of 5 thousandths and a rough pass of 10 thou. We're just trying to take off a little bit of the corner first before we come in with the final finish. We're only going to do one. We're not going to do multiple depths, and we're going to turn on smoothing. Okay, we're going to go to our next one. We're not going to do a vertical arced in lead in. We're not going to do one that's horizontal either. We're going to come in at 0 and we're going to increase that to 0.1. So we have a lead in that's straight coming in from the outside edge. Okay, we're going to accept that. And we have a Should have 2 passes. They're at full depth, 1 rough and 1 finish. Alright, so let's see what we've done so far. Done on our first side. So let's highlight our entire operation and let's do a stock simulation. Okay, we come in and do our drill. We come in and do a counterbore pocket. We do a finish on that pocket. We're machining the end. I could probably be a little more aggressive there. So then it's rough cuts at the end. Looks like it detected that my end mill flute length wasn't quite long enough. Comes in and does our radius. Okay, so we've just finished the first side and we're going to flip the part over. Okay, so we're going to use some of the same routines that we used on the first side. So what I would suggest we do, we duplicate this setup. So we're going to go right click on it and we're going to duplicate the entire operation. And we're going to at first go in and change the parameters. So it needs to be op 2. On our stock all sides, we're continuing from the previous job. And on the right hand side, we don't have any extra material. So I believe that's the plus sign. So if we set that at 0, we now have it at the size the block currently is. Okay, now we do need to change the faces. So we're using Z-axis. We're using the opposite side of the part as our Z-axis face. And our Y-axis face is the edge on the right. And our origin from now on, we want it to be a milled feature. Because the main focal point of this part is this bore here, I would want my fixture to be picking up on the center of that. Now, it doesn't appear that I can select an origin without creating a point there. I'm going to exit this stock for now. And I'm going to go to sketch and I'm going to sketch on the plane here. I'm going to create a point and I want to pick up on the center of this, the center of the arc here that's on the bottom of the part. And if we select that center point, we can create a point. Okay, I'm going to hide my temporary axes. And I've created now a point I can select on. Okay, so let's go back to CAM and exit this sketch. It's asking if you want to regenerate anything. Just go ahead and hit yes. And we're going to go back into our operation. Okay, I'm reselecting my model. I'm not sure why that wasn't selected. Okay, so we're going to keep it on relative size box, but again, we took off the point on the end. And now that we have a point, I can select the point I created in my sketch as my point of origin. Okay, so the bottom center of that bore, I can make a locating feature on a fixture so that it locates it with the origin there, and then I would use the end here that's been milled off square is our second fixture point that would lock this in place for this operation. And so that way we're controlling the concentricity of the bore on the opposite side to the center of this other feature. Okay. All right, so now scrolling down, we're going to call this 1392. It's the second program. And our program comment should be S60-139 op2. And we'll leave it at that. We'll hit OK. Okay, so now we're going to work on these routines. So they're all drilling in from the opposite side because the program was on the opposite side. And we're going to keep the countersink geometry. So we can go ahead and select that, and we select the countersink on the opposite side. And we're going to get rid of face 1. So we're just drilling on face 2. So we accept that. Now it's really just putting the chamfer in. We've already got the 1/4 inch holes actually already drilled all the way through. But this will add this chamfer lead in that helps the bearing press in. Okay, and we don't need the 1/4 inch drill, so we can delete that routine. And then we have a pocket command, so we're going to recycle that. We're going to go edit. And then we're going to do the same thing with our finish contour. We're going to delete the edge we have. I want an edge. Okay, we're going to accept that at default. And it looks like we got a problem here. It's trying to cut the outside. Let's try this again. Edit. We've got that selected. We're going to reverse direction and try it again. There we go. Now we got the inside. Now we're going to go to contour 5. What was contour 5? That cut the end of our piece. Okay, so the contour 5 at the end we don't need. We've already milled that off. And now we want to recycle contour 6, which goes around the outside edge. Now, what we're going to do is we're actually going to use the same edge we selected, and then we're going to add roughing cuts. So we're going to go edit. Go to geometry, we're going to delete this edge, and we're going to try a new chain. Start here and go around. And then we're going to go to our heights tab, and we're going to tell it we want to go from stock top to the contour. And again, we want to go maybe 5 thousandths deeper. That way we don't have any mismatch. And we need to make sure our clamping scheme would be clear. So I'm thinking we would probably have a clamp coming in from the end. And then we'd have a pin here, possibly a bolt, shoulder bolt, holding this end in and locating it. Alright, so we should be good there. We're just going to go ahead and go to the next tab, but we need to make some changes here. We're going to leave all this beginning stuff at default. We're going to do 30 thousandths roughing passes. We're not going to do that because once we cut all the way around, the outside material would go away. So we are going to do roughing passes at 30 thousandths, but we're only going to do 1 this time. We are going to use multiple depths this time because we're going deeper. And again, we're going to go with 30 thousandths. This might be a little too conservative, but and at the bottom we'll do a 0.005 pass. It's just going to be a spring pass. And we're going to finish only at the final depth. That works best in steel if you have enough flute length. We're not going to leave any stock. We're going to go to the next tab. We can leave all this, should be able to leave this all at default. We'll accept, and there we go. Okay, so we've got our rough cuts with a finish cut at the bottom. Now all we need to do is our radius cutter, which right now is cutting on the inside. So we're going to go edit, and I think if we reselect the geometry it'll be fine. So let's get rid of edge 1, which we don't want anyway because we want to cut on the top of our part. And we're going to select a new edge that's going to wrap around and accept that. And there we go. Alright, so we've recycled a lot of the code we used in the beginning. Okay, so we only have one more operation, and we're going to stand this up on end and do our machining on the drilled holes in the end. Okay, so this is going to be our last operation. Let's go ahead and orientate the block the way we would want it. And you know, we made this little point for our origin for the last operation. We want to make sure that is against the fixed jaw of the vise. If we were to mount a vise jaw and have a pinhole in it that a dowel pin could go through, if that was how we chose to fix this, but that this is the same edge we're keeping track of that we used on the last fixturing, which was the very first counterbore. Okay, I know it's a little hard to visualize with a symmetrical part like this, but I'm visually orientating the part so the bottom is facing up so we can do these drilling routines. Okay, so we're going to create a new folder, new job folder. Okay, and this one's going to be called the S60-139 op 1. I'm sorry, op 3. And we basically don't have any stock anymore. It's going to be from Solid, and we're going to pick our Solid model. Okay. And we're going to continue from the previous job. And our stock orientation is going to be Z and an X-axis. And then we're going to select the bottom of the part for Z, and our X-axis is already pointing the direction we want, but it would be this edge here, and we reverse it. We want it pointing to the right. And then our origin placement isn't going to be stock box point, it's going to be a selected point, and it's going to be that same sketch point we made earlier. So it puts it on the center of our round machined feature that would be our tooling point. Okay, so our program name is going to be 139.3, and our program comment is going to be S60-139 op 3. Alright, we're going to accept that. So the stock volume is the model itself. You know, technically you could have a box around it, but generally when I've machined all the outside features of it, we switch to that for collision detection. Okay, let's change the name of our job. It's going to be S60-139 op 3. I'll minimize it so I can sort them and put them in the proper order. Okay, this should go pretty quick. We're going to go with we're going to use spot drills, piloting drills, and then reamers and taps. Okay, so we're going to go first with our spot drill. Okay, we're going to go drilling. We're going to go with a drill. We're going to go to our library. We're going to grab our spot drill we've used before in this program. Our outside holes first. Okay, we're going to go to heights, and we need to calculate how far we're going. We're going from hole top, and then the second selection is going to be also from hole top, and we're going to go a negative distance of half the diameter of this. So we go to evaluate, measure our arc. It's 165 thousandths. So we're going to go negative 0.165 divided by 2. That'll give us the proper depth. We're going to go to the next tab. That's fine. We do want to slow down our RPM. Forgot to do that. Let's go 2,000, and we're going 10 inches a minute because we're steel. Now, if we wanted to be more efficient with this, we could have set up a library by material that had these defaults already in there, but we're not making very many parts, so we're just going to go with what we got. Okay, I'm going to leave all that the same, and we're going to leave the next the same. So we hit accept, and there's our first two countersinks or edge breaks. Okay, and now we're going to go and we're going to duplicate that routine, and all we're going to do is change the depth of this hole because it's smaller. So we go back to evaluate, and we're going to measure that lead in edge, which is 149 thousandths. Okay, so we right click on our drilling routine, and we're just going to go to the last tab, and we're going to put in negative 145 thousandths and divide that by 2. So it's going to go a little bit shallower. And our geometry, we're going to get rid of the two faces we selected before, and we're going to select just the center hole and hit accept. There we go. So when the machine actually runs it, you're just going to see it do them all together next to each other.